Good evening, everyone. I'm Kevin Long Kwan Q, and you can call me Kevin. Our SID is 1155094711. Our FYP, our final year project part 1, is about passcode-enabled wireless mesh network. So let's get started. So what is passcode? Well, passcode is a newly developed technology by CHK IE department, and it's a great tool for us to reduce the packet loss across the transmission. For example, like in conventional aids of transmission, we use routers, right? When we're transmitting data like video data, we will suffer packet loss due to a different passage of different routers. So the packet loss rate will be exponentially increased, and it is significant and its significant impact on our accuracy and our quality of our transmission. So passcode is by decoding the encoded data, and it can therefore reduce the packet loss rates in contrast to the conventional aid of transmission. And it also is applied to different intelligent industry in Hong Kong. For example, like the intelligent lamppost. The intelligent lamppost in Hong Kong is to measure different weather conditions like the humidity and the temperature of the air, as well as the traffic information. So it will or probably be used or applied in Hong Kong throughout Hong Kong. So passcode is a very useful future development. So speaking of our main character today is Raspberry Pi 0W. It's basically a small computer, as we can see. It contains everything we need. For example, like a USB cable port, a processor, and a SD card port, and also a power supply. So it can be able to connect to different peripheral devices like mouse and keyboards. So is useful for transmitting data through mesh network. And it's also widely used by different industry like education system, because the children can use it as a small computer instead of giving them a larger computer like a laptop or something like that. Our first task in this project is to format the SD card to eliminate anything we don't want. For example, like some random portion inside the SD card. So it's our first step. This diagram showed our interface on our Raspberry Pi. So as we can see, this is our desktop of the Raspberry Pi. It's very similar to a conventional personal computer like a Apple computer or Mac computer, something like that. And also in this interface, we are able to do the installation of the Raspberry Pi. Well, basically, after we have connected all the things we need, like the power supply, and we have configured the whole Raspberry Pi, then we are able to use it as a computer. So it's very convenient to, I would say, for us to connect the mesh network in the future. So our third step is to measure the network performance across different computers or even a mesh network. For instance, we have measured the network performance across two personal computers. This one is from a Windows computer. This one is from a MacBook. So basically, the IERG4998 software is able to measure different performance like this, the megabits per second, which is basically the rate of transmission. So we can see here as well. And also, we are able to listen to certain ports. And as a server, we are able to listen to the port, and as a client, we're able to do some transmission, etc. So it's a very great tool for us to measure the network performance in the future. So what's our future expectation or development? So we will continue working on building our mesh network with the aid of the Batman protocol, which I'll explain later, Besides, we'll implement the Basscode-enabled mesh network to see if any better performance is achieved. As I've just said, Basscode is useful for reducing the packet loss rates. For example, like across a certain distance or certain time, the Basscode is able to reduce the packet loss rates at a very significant amount. So what is Batman? Batman is not Bruce Wayne, right? Batman is a protocol we used in the mesh network connection. So in the future, we'll use the Batman protocol to connect through the entire mesh network. It's to transmit data to and from multiple directions without delay. And it's also decentralized. So what is this concept? What is decentralization? Decentralization is very important as it is none of the nodes that has all the data, right? It suggests an advantage of this protocol, which is not every node need to have the same piece of data to know everything of the network. So the efficiency is enhanced because the requirements of data amounts of each node is less than that of other protocol, for example. And also the Batman is able to let the node to know only the previous node's information. For example, like when we're transmitting from node 1 to node 2, we only have to know the previous node, which is node 1, the information of node 1. And also the network is able to generate routes dynamically and to transmit the data with independent routes. So it's a very flexible approach when it comes to mesh network transmission. So it's always about the next step. So what's the next step from node 3 to node 4? So what's the next step from node 5 to node 7? So it's all about thinking of the next step. So it's about the dynamic nature of Batman protocol, which is a very distinctive feature of this protocol, apparently. And the last thing is no looping. Batman has no looping feature, which means when we are circling the transmission, like from node 1, node 2, node 3, node 4, etc., the packet transmission won't go back to the source node. For example, like node 1, which is the source node, it won't happen. So it's a very efficient feature for Batman that it does not contain looping phenomenon. So it's pretty much how it works as a Batman protocol. So we'll continue to work out our program and our analysis of Basscode performance. So that's the end of our presentation. Thank you very much.